On to problem number 7. We have for the molecule shown, draw a stereo and structural isomer as well as a different conformation. Okay, so first we want to name the compound we're given. So let's zoom in on this given molecule. Looking at it, we know right away that it has 2 branches, and we have to number those. So 1, 2, 3, and 4. So we have a 1,4-cyclohexane, and we can tell whether these branches are equatorial and axial. Both of these are equatorial because if they were axial, they'd be pointing more upward or downward. Okay, let's clean up a little and zoom back out. So we can name this 1,4-EE. Since from our table we know that 1,4-EE is trans, we know that it is a trans dimethylcyclohexane. Okay. Another way we can do that I use, since I don't like memorizing those tables, is I look at the 1,4 and I look at the numbers themselves and I say if they're even or odd. Since I know 1 is odd, 4 is even, I know that the cis follows the same pattern as this. So if it was a cis 1,4, this would be axial equatorial. The letters are different here, the letters are different over here. And since it's not that, I know that it's trans because it didn't match my memorization technique. Okay, now we know it's a 1,4 trans. We can look at the structural isomer. Structural isomers just have different connectivity. So basically it has slightly a different name, not counting the cis trans and RR before it. That means you can change a 1,4 to a 1,3, a 1,2 cyclohexane, or you could change it to having just a single branch, or you could just change the whole ring itself. There's a lot of ways you can change this molecule as long as it has the same molecular formula and isn't look exactly the same. You're usually fine. So I'm going to draw, let's do a 1,2 compound. That'll give us a slightly different compound. It's not the same. It's not a stereoisomer either because it's a completely new name. Another thing you can do, like I said, is put them all on the same branch. So I can put 2 carbons on the side of 1 branch, and that's a different structure as well. You could also just do a different ring, move it to a double bond. There's a lot you can do. Okay, now looking on to the next, we want to draw a stereoisomer. Stereoisomers have different spatial arrangement. So our R and S a lot is the way we use it. These molecules, even though they look the same and are connected the same to the same things, they're not the same. The best way to look at this is trying to make them match up. I can put this green top to face north, but I'll never get the other 2 to match it. Because this guy, basically his right hand's a hydrogen, and this one's right hand is blue for a nitrogen. Nothing I can do to make them the same because they're chiral. They're mirror images of each other. So I can do that to this molecule by switching between trans and cis. A switch between trans and cis will facilitate the same theory. Okay, so let's zoom in. We know that on that we were trans at E and E. So to make it cis, we want to make it axial equatorial. So to do that, we'll redraw it at the same positions. We have 1, this was 1, and that's 2, 3, and 4. So now instead of drawing equatorial, we draw axial. Axial and equatorial. So that would be trans instead. That would be cis, sorry, instead of trans. And for our last one, we want a conformational isomer. Conformationals have different rotations about single bonds. In a ring, that would look like switching from let's say trans, since it can be in this case EE, it can also be AA. And the reason for that is if we look at our cyclohexane ring, let's make it the perfect way of looking at it is the ring. We can make this slightly different by switching the chair conformation. So I'm starting off and it's trans because one methyl is facing down while the other is facing up. And this is before we went into the chair. An easy way of looking at it, let's say, is to look at it from the 1-2 position. At this spot, we're at trans already, up and down, and I can't really change that with the ring flips. If I can move this on the same side, we'd have cis. So we want to make this a 1,4 carbon and trans. So one's going to be facing up and the other's going to be facing down. And now we want to make a tripod to go in our 6-member ring in the chair conformation. So I grab 3 at opposite ends, and that'll put me in a chair conformation, if it looks just slightly familiar to you. And now I have 2 axial position, which we started off with equatorial, so if I want to switch between the 2 conformations, all I have to do is rotate these single bonds by making a tripod again. And now I have 2 equatorial carbons instead of the axials. I'll do a ring flip again. You just grab 3 equatorial sides and pull down to make a new tripod, and we have these methyls in the axial position instead of equatorial. Because of that ring flip, it's a conformation. We're just moving single bonds. Okay, so if we wanted to draw that out, we would have to draw the different conformations. So an EE switching to an axial. Okay, so 1,4 axial will point. One will be pointing up. And one will be pointing down. Okay, and now we'll move on to problem 8. What is the relationship between these 2 structures? Using the same thing we just learned, we can look at these and name them. First, we'll start off with a simple chair since we just did a couple. And this is pulling slightly right and right. So both of these are equatorial position. And we can number them 1, 2, 3. So we have a 1, 3, equatorial. They're both of these are odd. So a cis would have the same letters. So I know it's cis 1, 3. Now looking over at our other ring conformation, we have to be able to name these. The relationship between that circle given to us out here and the little crosshairs is the circle is a carbon and the crosshair is a carbon. So this is really 1, 2, 3. Then we look at the circle, and the circle is 4. Then back here is 5, and the next circle is 6. And we can tell that the crosshair is connected directly to this methyl, so the branches are at 1 and 3. But in this one, they're both axial. This H over here is the equatorial position on the crosshair. And this, if you wanted to look at the circle instead, the circle is your other carbon. So this H is on the 4 carbon axial position, and this H is on the circle carbon equatorial position. Okay, so we know that both of these methyls are axial because they're both on the crosshair carbon down here, and they're both pointing up. So we have 1, 3, AA. Again, also cis. But because both of these
are cis, but different connectivity, not different connectivity, different rotations along the single bond, we fall into our definition of conformation. Therefore, these two are different conformations, since one is in the axial position and the other is in the equatorial position. Therefore, you're just flipping these in your ring structure to give you those two different positions. So they're not structural, stereo, or different drawings, they're just different conformations of the same molecule.